Okay, so we've already been working on like balancing equations and things like that, so we're just going to quickly zip through this because we already know how to do the balancing. But we want to move from there to being able to predict the products of a chemical reaction, look at the steps we have to follow in order to do that, and then give a few of those a try. Kind of going forward here, guys, when we come back from the break, probably that first day back, we'll be in the lab, probably. Okay, doing our lab on chemical reactions, either Monday or Tuesday. And then we're going to finish up reactions kind of middle of that week, move on to mole equation, which will take us through the next week, and then you'll have a unit exam. So probably somewhere around, the second, like 2 weeks after we get back. Okay, somewhere in there. I'll put a date, it's kind of set in stone date when we get back from the break, but expect it's going to be about 2 weeks after we get back. So that's kind of what to expect. And so I've had a few people ask, like, what should I do over the break? And my gut answer to that is, have a break. That's okay, right? Do you need to look at your schoolwork over the break? That's not a bad idea. Don't spend your whole break doing that, though. Okay, that's not healthy. You're getting a break for a reason. I can't remember what it is, but you're getting one, okay? So my suggestion to you, if you wanted to just take a few minutes, because I don't want you to spend a lot of time over the break, take 10 minutes one day and just try a few of the naming stuff. You've got a key for the naming worksheets, so you can try just a few at random and check the key. Make sure you know how to do it. Try a few reaction problems. You've got keys for those from the workbook as well. Okay, see if you do them right. If you don't, then just make a note of that and you come and see me for help when you come in. Okay, or ask those questions when you come back. But no, you don't have to spend your whole break studying, okay, or working on stuff. Like, you don't have anything due from me when you get back. Okay, so yeah, take a few minutes here or there, do a few questions, but take a break. That's what it's for. All right, so for our key points for today, kind of just looking at the balancing part of it, understand that the amount of atoms on the reactant side of an equation, so on the starting side, okay, must be the same as on the product side. Otherwise, you're breaking the law of conservation of matter. You're either creating it or destroying it, which you can't do, okay? Use coefficients to balance equations. You guys already know how to do that because we've been doing it for like a week already. Okay, and then obviously understand matter cannot be created or destroyed. The whole reason we balance chemical reactions in the first place. All right, so like we said, the law of conservation of matter, or sometimes called law of conservation of mass, okay, basically says that when you have a chemical reaction, you have to have the same amount of stuff on the other side. So in this case here, where I'm combining 2 hydrogen molecules that contain 4 hydrogen atoms to 1 hydrogen molecule which contains 2 oxygen atoms, I get 2 water molecules which contain 4 hydrogen atoms and 2 oxygen atoms. So I have the same amount of everything on both sides, and that's why we do that whole balancing thing, just to make sure that that's always the case. Okay? And since we have already done that and we already know how, we're just going to skip those steps. And we're going to talk about predicting the products of a chemical reaction. All right, so I would like you guys to write down this first reaction here. Okay? In this first reaction, we have calcium reacting with oxygen. Okay, so what kind of reaction starts out with 2 elements reacting with each other? Synthesis reaction. Okay, so in a synthesis reaction, these 2 elements are supposed to do what? Create a compound. All right, so if these 2 elements go together to make a compound, what kind of compound will it be?
Ionic?
It'll be ionic because calcium is a metal and oxygen is a nonmetal. Right? So I would say on this side then, I would have calcium and oxygen. Since I just made an ionic compound, what do I need to check about it?
It's charged.
Yeah, I got to do the swap and drop, make sure that this is actually the way this compound looks. Calcium is a 2 plus. Oxygen is a 2 minus. So yes, in fact, that compound is good the way I have it written. All right. Was that very hard? No.
Is there going to be a question where you have to predict it and then you have to write it out and then like go back in like all the steps all at once?
Like write it out in words?
Yeah.
No. No. When we do prediction, it's just going to be formulas. Yeah. I might give you the reaction in words to start with. So I'll qualify that. Yeah. I might give you, like I might write calcium plus oxygen in words, and then you would have to get to this, but we don't go back and have to write it all out. All right, so what's left to do? Balance it, yeah. Okay, so I've got 2 oxygens on this side, that's the biggest number. So I put a 2 here and my oxygens are balanced. A 2 here and my calciums are balanced. And I'm done. Okay, so all there is to doing these is knowing what patterns the reactions have. Once I know what happens in each of the 5 reaction types, it's pretty easy to figure out who's going to end up with who on the product side of a chemical reaction. Okay. Okay. Give that one a try. See if you can predict the products for that one. All right. What kind of reaction starts with only a compound? Yeah, decomposition reaction starts with just a compound. So this is going to break down into magnesium and sulfur. Okay, is there anything I need to check about those 2 things?
The S is special.
Yeah, the S is special. Okay, it comes as a what? As an 8. Okay. So there's little things that I have to remember, but they're no different than the little things I had to remember when I had the whole reaction. Okay, I still have to remember that sulfur is special. All right, so now that I've done that, what's left to do? Balance. Okay, they're really not that tricky. It's no different really than what we were doing before. Okay, so the steps go like this. Identify, write out the reactants if they're not given to you like this. Write them out in formula form. And then determine what type of reaction is happening. Once you've determined that, use the pattern to figure out what the products will be. Drop and swap any ionic compounds. Check for special elements. Balance the reaction. Okay? Basically the same steps we did before, except you have to predict them instead of having them written out. Okay? All right, try this one. So what type of reaction is that one? It's a combustion reaction. Yeah, we got carbon and hydrogen reacting with oxygen. What are always the products of a combustion reaction? Carbon dioxide? And water, right? Hydrogen's part of it, yeah. Okay, so for combustion reactions, this is actually easier because it's always the same 2 things. Right? If it's a combustion reaction, you just write CO2 and water and you're done. You don't even have to think about it. Okay, it's just a memorizing thing. All right, what's left to do? Balance. Okay, do I need the rule of 2 for this one? No, 3's an odd number. Okay, so I'm going to put a 3 here. What do I need to put in front of the hydrogen over here? A 4, yeah. Okay, so that gives me 4 oxygens plus 6 more is 10. 5 times 2 is 10. All right, give that one a try. Okay, so first step, what kind of reaction is it? It's a double replacement reaction. They're both ionic compounds. Okay, in a double replacement reaction, what do the metals do? They swap, yeah. Okay, they just switch partners. So I'm going to have Na with Cl, and H is going to go with OH. Okay, I just swap the metals.
Does it matter if the HOH is first, or does it have to be second?
It has to be seconds. Although, in this case, it would look the same. Oh no, wouldn't it? It would be OH2, sorry. Yeah, the H has to go first because we're writing it as an ionic compound, right? So we want to have the metal first. Okay, so now that I've got those written out, they're both ionic compounds. What do I need to check about them?
Does the order of this, like NaCl and the HOH matter?
Doesn't matter. I could have written NaCl second and HOH first. That doesn't make any difference. Yeah. Okay, what do I need to check about these? Yeah, charges. I gotta make sure the drops and swaps are done correctly. +1, -1, +1, -1, we're good, okay? So, are we done balancing too? Yeah, okay, everything's a 1, there's no little subscript numbers, so we're done the balancing. All right, so double replacement and single replacement are probably the trickiest ones, just because there's more stuff to move around and manage. I would say that actually single replacement reactions are the toughest, okay? And the reason for that is there are gonna be ionic compounds that have to be dropped and swapped that are gonna be formed. And there's a chance that special elements could also be formed, and we need to remember to check for those as well. Okay, so on that note then, where's it? Oh, I didn't make a single, okay. Well, I'm gonna put one at the bottom of that screen there. Okay, well, let's get a single replacement reaction here. So let's say, give that one a try. I spoiled it, it's a single replacement reaction. Okay, so as I was saying there, when you have a single replacement reaction, you have an element reacts with an ionic compound, it's got to produce another ionic compound with a different lone element. Okay, now in this case, the element that's reacting, that's by itself, is what kind of element? Metal or non-metal? It's a non-metal. So I look at that and I say, okay, the only thing it can swap out with is the non-metal in this ionic compound. So basically the rule for single replacement is you swap the like elements. Okay? If the lone element is a metal, you swap it with the metal. In this case, it's a non-metal, so I swap out the non-metal. Right? And what I'm going to end up with is this ionic compound and this lone element. Right? And as I said, the trick with these is that I'm going to make an ionic compound that needs to be dropped and swapped, and there's a chance that I'll form special elements that I also need to check for. Did both of those happen? They did. They both happened. I mean, I'm always going to get an ionic compound in a single replacement reaction. Okay, that's a +1, that's a -1, so that compound is okay. Is oxygen special? Yeah. Right, so I need a 2 there. Okay. Now I've got to balance it. So biggest number is 2, and it's present on all of them at one point. So which one should I start with? I would start with the oxygen because it has the biggest charge. If you've got a bunch of numbers, they share the same biggest number, start with the one with the biggest charge. It's going to have the biggest effect on the reaction. Okay, so I got 2 oxygens over here. Now I've got 2 over here. How many lithium does that give me? 4. Okay, how many chlorine does that give me?
4.
2. Okay, is that making sense? Right, like I said, it's not really that much different. You're not doing anything really new here that we didn't do before, okay? Other than you don't get it all written out for you. Okay? But it's not hard to figure out who goes with who. Okay. All right, well, let's have you guys try the first 2 here. Okay, see how we do with those. Okay, is number 5 about the easiest one ever? Yeah, okay, so we're going to have, what kind of reaction is it? It's a synthesis reaction. Okay, in a synthesis reaction, I simply combine the 2 elements into a compound. What kind of compound am I going to make? Ionic. Beryllium is a metal, iodine is a non-metal. Okay, so I'm going to go Be, which is a 2+, with iodine, which is a 1-, and I'm going to drop and swap to get BeI2. Okay, and now it's already balanced because, well, I picked bad ones and that was way too easy. All right, have I followed the same set of rules every single time? Identify the reaction type, okay, use the pattern to predict the products, drop and swap ionic compounds, check for special elements, we didn't really have to do that on this one, okay, and then balance the reaction. Always the same set of steps. All right, so looking at number 6 then, what kind of reaction is number 6? It's a single replacement reaction, and this time the lone element is a metal. All right, so what part of iron 2 oxide is potassium going to replace? It's going to replace the iron, right? Okay, so that means iron is going to end up by itself, and potassium is going to end up with oxygen. All right, so I identified the type, I used the pattern to figure out who goes with who. Do I have an ionic compound? What do I need to do with it? I need to drop and swap the charges. Okay, this is a +1, this is a -2, so K2O. I have a lone element, is it special? Iron's not special. Okay. Hurts its feelings, but it's not. Okay, it just is a 1. All right, so that part is good, and now I just need to balance the whole reaction. The only thing that's out of balance right now is potassium, so what do I do? Right. Okay, everybody good with that one? All right, just making sense? All right. Get ahead of me. Try those ones. All right, so for question number 7, what kind of reaction am I looking at? It's a double replacement reaction. They're both ionic compounds. Okay, in a double replacement reaction, the metals swap partners. Okay, so that means then that copper is going to end up with chlorine, and magnesium is going to end up with sulfate. All right, now there's a little bit of a trick with this one. Copper has more than one possible charge. Can I figure out which one it is from the reactants? And I have to, because otherwise I won't be able to drop and swap it on the other side. All right, so since sulfate is always a -2, and these are 1 to 1, this copper must be +2. All right, then I know that on this side copper's a 2, chlorine's a 1, and I've got CuCl2. Okay, and then I also need to drop and swap this one. It's a +2 and a -2, so it's okay the way I wrote it. Everybody all right with that? Any special elements to look for? Not in a double replacement reaction. Okay, what's my last step? Balance the reaction. Okay, okay, good. It's already done, right? There's 2 chlorines on each side, 1 sulfate, 1 magnesium, 1 copper. And the rest of it's good. All right, for number 8, what kind of reaction are we looking at? It's a combustion reaction. What are always the products of a combustion reaction? CO2 and water. Okay, do we need to use both rules? Yeah, we always have to balance alphabetically, but we also need to use the rule of 2 because 4 is an even number. So start with a 2. 2 times 4 is 8. Now I have 8 carbons on that side. 2 times 10 is 20. 10 times 2 is 20. I have 20 hydrogens on both sides. Now I can look at the oxygens. 8 times 2 oxygens is 16, plus 10 more oxygens in the water is 26. 13 times 2 is 26. Okay. Everybody all right with that one? Okay. How many people have done number 9? Okay, let's look at 9. What kind of reaction is 9? It's a decomposition reaction. There's only one reactant. The only thing it can do is break down. There's nothing for it to react with. All right. So when it breaks down, it's going to break down into rubidium and phosphorus. Okay. In a decomposition reaction, I do need to be mindful that I could produce special elements. Did I?
Yeah.
Yes. Which one? Okay. And what does it come as? Right. Okay, rubidium is a metal, it's not special. Okay, so now we need to balance the whole reaction, starting with the biggest number, which is phosphorus. Putting a 4 there balances my phosphorus, but gives me 12 rubidiums. Now we're balanced. Can't make it any lower than that. Okay. All right, I'll give you a couple more minutes on number 10. On number 10, you have to think about one of the things we did up here in number 7 with copper, because you have 2 metals with more than one possible charge. Okay, let's look at number 10 here. Oh, I had that recording the whole time. That's nice. Okay, what kind of reaction we got? Double replacement. Yeah, they're both ionic compounds. All right, so in a double replacement reaction, we're going to swap the metals so that they have new partners. So that means then that lead is going to end up with phosphate, and cobalt is going to end up with chlorine. Okay? Now, I just made 2 ionic compounds. They both need to be what? They both need to be dropped and swapped. Okay, but to do that, I've got to figure out what charge they had over here on the reactant side, because lead can be a 2 or a 4, cobalt can be a 2 or a 3. Okay, so I've got to figure out which one is which. So for the lead, chlorine's always a -1. There's 4 of them, so that's 4 negatives. That means that this must be the lead with the 4+ charge. Okay, phosphate's always a -3. So when I drop and swap, I'm going to get Pb3, PO4, 4. Okay, everybody all right with that? Got to do the same thing with cobalt. Phosphate's a -3. There are 2 of them. That's 6 negative charges. I got to get 6 positive charges divided by 3 cobalts. This is the cobalt with the 2+ charge. So 2+, 1-, COCl2. Okay, biggest number in this equation is 4. And it's attached to both chlorine and phosphate. Which one should I start with? I should start with the biggest charge, which is chlorine or phosphate. Phosphate. Phosphate's a -3. Okay, it's going to have a bigger effect. So I've got 4 phosphates over there, so I'm going to come here, and what am I going to have to put in front of this to get 4 phosphates? A 2, yeah. Okay, 2 times 2 is now 4. All right, when I put that 2 there, it gives me 6 cobalts. So I've got to go over here and put a 6 in front of the cobalt. When I put that 6 there, how many chlorine does it give me? 12. All right, so I got to go back over here. What needs to go in front of this?
3.
Uh-huh. And when I do that, does that make my leads work? Always a good sign. Okay, there's 3 leads over here, so that was a good choice. Okay, now we're balanced. That's about as tricky as they get. Okay, where you've got to do a bunch that have more than one charge, you got a polyatomic ion in there. Okay, yeah, that's about as tricky as they get. All right, that'll put some pieces. Yep. All right, is this starting to make a little bit of sense? Okay, feeling okay about this? It's not, like I said, it's the same skills you were using before, and we're just applying them a little bit differently. All right, take about a 3-minute break. Okay, guys, I want you to try those 3. Okay, do those 3, call it a day. So for number 3, we got magnesium solid reacting with nitrogen gas. What do I need to remember about nitrogen? It's a 2. All right, that's going to form what kind of compound? It's going to form an ionic compound. So Mg first, N second. Okay, if on a quiz I flip those 2 things, I think I told you this the other day, right? A lot of people write NMG, okay, without thinking about that an ionic compound has to have the metal first. -3 plus 2, so we got Mg3 N2, so we've dropped and swapped. Okay, we already checked for our special elements. We got to balance this thing. Now it's balanced. We're good to go on that one. Okay. For number 5, iron 2 sulfide. So the Roman numeral tells me this is the iron with the 2+ charge. It's with sulfur, which is -2, so that's good. Okay, and it's with oxygen gas, which this question kindly reminded you was special. All right, what kind of reaction is that? Single replacement. All right, so oxygen is going to replace sulfur. All right, so I'll have FeO. That's a +1 or +2 and a -2, and I'll have sulfur by itself. Very special. Okay, and so we'll have an 8, an 8, and a 4 to make that one work. And then lastly, molybdenum oxide. So molybdenum is MO, and it's with oxygen, and it's a 6, right?
Yeah.
Yeah. Okay, so molybdenum is a +6, oxygen's a -2. 6 and 2 goes down to 1 and 3. Okay, reacts with hydrogen gas, which is a metal. What kind of reaction is this? Single replacement. Okay, so we're going to have hydrogen with oxygen and molybdenum by itself. Okay, and so when these 2 go together, it should make something that looks like that. Okay, and then when we go back to balance, we got to balance our oxygens. So we got 3 and 1. If I put a 3 here and a 3 there, I think the whole thing works. All right. Okay. Have a good break. Don't work too hard. Take a break. And we'll see you when you get back.